Welcome to Never Rewrite. I'm Isaac Askew.
And I'm Jeffrey Sherman. And today we are joined by special guest Josh Beckman, who is going to tell us about the transition from microservices to monoliths. So, Josh, why don't you start by telling us a little bit about yourself, who you are, your background?
Cool. Yeah. So it's Josh Beckman. Sorry.
Sorry.
But it gets confused literally about 75% of the time. So no worries there. And yeah, so right now I work as a senior staff developer at Shopify, specializing in the extensibility of Shopify, that area. And today I think we're going to talk about some microservices to monolith migration I did at the last company I worked at, which is called Office Love, which is in Chicago. And one of your previous guests actually worked there with me. Sorry, I had shared a previous employer before that with Colleen Grafton, who was one of your previous guests. My history here is that, so I'm in Chicago, and I've worked at various number of small startups over the last 10 to 12 years here in the city, and then switched to Shopify during the pandemic when they went remote.
I was going to ask, does Shopify have a big presence in Chicago?
So I was the first or maybe second developer that they had in Chicago. Now we have more, which is great. So I joined in 2020. But it's been getting bigger, yeah, for sure.
Awesome. So let's kick it off. So you at the Office Love, you had microservices, and you decided to move them to monoliths because that's the hip new thing that all the cool kids are doing.
Yeah. So the history of me there at Office Love. So I joined that company at a very early stage. They had two co-founders who were non-technical, and they had hired a consulting firm to build out the initial version of their product. It's a SaaS product that allowed offices to contract cleaning and maintenance and staffing services for their office spaces. Okay, so that's what it was when I first joined. I was the first technical person to join that company and took over the existing code base. That existing code base was a Rails monolith. If you read the code, very much written by a contracting agency who wrote it in a small amount of time for the lowest budget possible. So I joined in, and
so it was awesome.
It was no problems. Definitely not a bunch of manual rake tasks that you had to run every day to keep the product running. So I joined, and I saw that system, and I had previously come from a company where we had been running Node microservices. And in that company, we saw major benefit from that. That had been a PHP application decomposed into Node microservices. So I joined Office Love, saw this system and all the work that we wanted to expand it into, and decided to start spinning up Node microservices to handle that. So these were basically Express, or Koa was fancy and new at the time, Node-based microservices. Some of them, which is not good, sharing database, but most of them having their own individual databases and actually being microservices. So I was looking through my notes in preparation for this, and I had an architecture diagram that I prepared to explain to the co-founders what their current architecture was that I had inherited from the agency. And there was a single monolith, and there were a couple small databases on that diagram. That was in 2015 or 2016. The next year in my notes, I had another architecture diagram that I had created of oh, now it's the current state. And there were 9 microservices in place of that one macro service or monolith.
And so, did that work better in the beginning?
It got us a lot of functionality very quickly. Okay. At that time, though, it was me and then one other engineer that we had at that first year mark. And that one engineer was relatively junior, and so they didn't question a lot of that stuff that I had done. But everything was working fine. There were no problems with things, but you could see this the water spreading across the land of all these systems you have to maintain.
Right.
So after about a year of operating that way and us spinning up even more microservices, maintaining all of those, maintaining dependencies, similar monitoring schemes for all that. Also, you're at a startup, so costs are important to keep down. And every service you operate, generally for any kind of monitoring or bug snagging or whatever systems, you pay like per tenant or something like that. And so those costs are going up, even though they are small microservices. Deployment times didn't go up for any individual one, but like rolling out a feature now constituted a sequential rollout amongst those different services so that you could like have a fully working end-to-end feature that required updates and or new features in many different layers of that stack.
Orchestration became a word.
Correct. And only the engineers, me and like this other person, would know how to like orchestrate that rollout. So we ran like that for a little while, and then we started having to do optimizations. So optimizing things like, okay, now this microservice has gotten thick enough that we have to do special optimization in terms of like the data fetching, caching layers, that kind of stuff. And so you start having to replicate the optimizations now across those different areas. You start having to decide whether you're going to make individual packages that you then share amongst those. Now they start to feel much less like microservices if they're sharing a bunch of things between each other. And then we started hiring more engineers. So hiring 2 to 4 engineers maybe in that second or third year. And onboarding new engineers to this becomes slower and slower for all the microservices you add to that system. Because now anybody starting to build a feature in one area, some of that knowledge is transferable over to another microservice, but kind of the whole point is that they're different. And also, we took advantage of different languages for those different microservices.
Most of them were in Node. How different were it? Some are in Node.
Most of them were in Node. We had one that was in Elixir because we had very, very long-lived connections that we needed to maintain for this one very specific vendor that we had to integrate with. Another one was written in, another one was an API gateway that was written in Lua. And then there was a fourth one that was written in, it was initially written in Go, and then we rewrote it to be in JavaScript as well. But yes, so like not one language. And then again, what used to be the monolith is still existing, because it's the like admin interface for people, and that's a Rails application, right? So now you have still things that are spread across those different languages.
So in year 3, if I can summarize and paint the picture, you've got somewhere around 15 to 20 services, including the monolith. You've got at least 5 languages going, right? You've got Rails, you've got Lua, Node, Go, Elixir. Node, Go might have fallen out quickly, but 4 or 5 languages, 15 to 20 services, 5-ish developers. And it sounds like from a business standpoint, it was working fairly well. Like you were able to produce and ship lots of features. And so was the business, and I can see how the expenses were going up from the business perspective. Did the software work well? Were they satisfied with the software? Maybe not with the cost of the software, but like, was that part good?
Yeah.
Was the customer experience good?
No complaints from the customers. Like they didn't notice any degradation or anything. And we were still able to ship things relatively quickly. But we were having to pull along more and more weight in tech debt as a small technical organization in order to deliver that stuff. So increasingly, we were having to either neglect certain services that like, oh yeah, we haven't had to make any change to this area because we haven't had a new login system that we need to, or we haven't had any changes to the OAuth system that we need to like support. But now that's been sitting there untouched for like 2 years. Now we need to do dependency management more and more for that stuff, or we neglect it in order to build new features. And I would say that the biggest hurdle was in onboarding new members. We saw more and more of that cognitive load slowing people down from contributing meaningfully across different features or across those different services. People would become very confident in like one small particular area, and it wouldn't translate well for them into other areas.
Yeah, I have a lot of experience, I think, uh, with I guess helping onboarding for services that become complicated like that. Because what you'll have is you'll have like one service that people forgot to update the README for, and maybe they made a bunch of changes to, and then you finally it's not a problem until a new person comes on, and then you realize, oh, no one's ever. It's been running on everyone's local, system for a while. No one thought to update all these, environment variables or things that we needed to actually run the thing until some new person comes along. Multiply that times 5 services, or like, oh, to spin this up locally, you also have to spin up the API service locally, and they all service locally. I can just see that cascading into like a nightmare situation.
Mm-hmm, mm-hmm. Yeah. And luckily, we didn't get to a nightmare situation. Mostly what we got to is me looking at our backlog of tech debt and saying, we can either start tackling these individually and solving these problems that we've laid out, or we can try to obviate the problems. What could we do to just entirely get rid of that? So some of the initial like presuppositions, assumptions that were used to like justify the multiple different services, where we can have more performant optimizations for each of these individual jobs that every microservice is doing by specializing each of these different services. Okay, so that's one assumption. Second assumption is that they are isolated enough that they will not need to share hardly anything between them. And third is that they should be like relatively easy to like onboard onto, and like it should be low cognitive load. So let's go through these 3 assumptions. So the first one of performance, we started seeing that like, no, actually the performance is generally the same for a lot of these. It's a SaaS app. A lot of it is CRUD in some squint or another. And we started needing to have to do basically the same optimizations in multiple different places. And we were writing these things in Node, and at the time, like Node was starting to get up to date on like ORMs and that kind of stuff, but we weren't using it. We were basically using the bare like Connects wrappers, if you're familiar with that stuff. So like building a lot of your own bespoke like ORM like things to do optimizations around database querying, which is 90% of what a SaaS app is doing. So that's one thing. So that performance assumption was being disproven. Second assumption around, we can, what was my second assumption that I laid out at the beginning?
Isolation.
Oh yeah, isolation. They don't need to share anything between them. We started seeing that breakdown as well, where this performance was we needed to start sharing it between them. But then B, they started needing to reference like these thick, fat models around like, what is the company? What is the user? Whose team are they on? What abilities do those different things have? Because this was a like a B2B product. And so there's a lot of permissioning that we started needing to build in around who can do what and what abilities do you have, and how does that translate across these different services? Because any given ability, any given ability would very often have repercussions in multiple different domains, such that they would touch like any ability, like, you can send invoices. That might touch multiple different microservices because they're like actually different domains that constitute that one like ability for you. And breaking those abilities out by like the microservice domain like wasn't useful for the customer, and so it would be not ideal. And then the third one, the third assumption around it's easier for people to onboard and they can like come up to speed very quickly. I thought that was going to be true. JavaScript, Rails, I thought that like Elixir would be close enough to Ruby for things. But we started just not seeing people be able to do that as much. And we started, we hired a lot of like bootcamp graduates as well. But any small uptick in that like learning curve has like compounding like slow down effects on things. And so anything you can do to reduce any kind of cognitive load has compounding benefits as well to avoid that stuff. So those 3 assumptions really were being disproven by all that stuff. And so I started looking at, okay, what would happen? How would it look if we muted all of these different things back into like a single system? And what would that look like?
I hope it looked like PHP.
No, not quite.
Perl?
It looked like I took a look at all those different services and I said, okay, let's say we wanted to reduce it down to one. Would it be a different one service, or would it be one of the existing constituent services that is like the most important or the heaviest like load bearing one? And in drawing that diagram, I mentioned we still use this one like Rails system or Rails application to do the administration. Like our internal employees at the company would use this to do administration around like, oh, setting up customers, doing maintenance and or customer maintenance or doing support, that kind of thing. And so like that was always going to be there, right? We always needed to maintain this like level of customer service, regardless of what other features we ever started offering or took away. And so this was like the load bearing thing that got used every single day and was where we ran all of our maintenance jobs, all that other kind of stuff. And so started to think, okay, if this is the one load bearing piece, and Rails is pretty good at doing a lot of different things, been around for a long time, can we standardize on this? And so I started looking at like proving that out.
So wait, before we continue, I gotta ask. So we're 2 or 3 years in at this point. So would the SaaS control plane is it's in Rails and it's the linear descendant of the code that you inherited from the contractors. It sounds like it's mostly CRUD and it probably is mostly being rewritten at this point. So it's not terrible contractor code. It's just CRUD that there's no pressing reason to rewrite because it's just CRUD in Rails. That's what Rails does really well. Okay.
Yep. And if you're familiar with Rails, it was mostly active admin was what was being used to like do the administration for the internal employees. And so like very well-trodden libraries around that stuff. Most of the contractor code had been cleaned up. There were a few like low-level model interactions that were still there that weren't like pretty, but could be worked around and could be refactored if we spent time on it. But what the main differentiator that I saw as I started looking at, like, how would we combine these things down? Well, we can migrate the data over, we can copy these tables, everything's on Postgres in different systems, but we can copy that stuff over. We can tolerate a 5-minute downtime to like do this cutover in this one system. But what are the big differences here? So one is obviously like the language, you have to rewrite things quite literally. And two was that we did see significant performance benefits in those node microservices compared to a traditional like Rails API like controller and Library. So I started looking at, okay, what would it take for me to get that same Node.js performance in our Rails applications? So I started looking at different libraries, and I found a library that I really enjoy and I would recommend people check out. It's called Rhoda, which is just a very simple routing library that is optimized for speed and conciseness. So basically, if you go look at like the Rhoda library, you'll see it's basically all just like Ruby blocks that like descend into a nest that like build up your routes, and you can decompose things differently if you want. But it's all precompiled routing. So that's like very fast, and any like latency is going to be down to whatever you do inside that block. So if you can do things like smart eager loading of data with active record and stuff, then you can get basically very similar performance to what you would get with Node if you then start wrapping things in threads and that kind of stuff. So I built out some prototypes of, okay, let's take these select routes that are the slowest in our node system, and these ones that are the fastest in our node system, and replicate those in this Rails monolith and see if I can get them to within some like limit of or some like range of their current like speed. I forget what my target was. It's probably like within 10% or something like that. And the initial copy over did not do that, but I did some optimizations, and like you can tune things with these libraries and stuff like that. Did some like threading manipulation, and got it to work. Okay, wasn't pretty at that point, but like we got like speed parity.
I have to ask, just
Mhm.
sorry to interrupt. Did you consider consolidating? Like, did you consider it, and would there have been any benefit from, instead of going to just standardize on one Rails monolith, standardize on a Rails monolith and a Node monolith, and then maybe just your Elixir hanging out there? But that would have, maybe reduced your cognitive load without fully requiring rewrites.
Yeah. So I started looking at, I did look at doing that as well. The problem was that, or the problem I saw was that we had so much, like the optimization logic that we were currently doing in Node was all based on like that raw SQL adapter of like connects, no like ORM logic. And because we were starting to have to really complect a lot of these domain models together to get this like advanced business functionality as we were starting to evolve the product, we really started missing the benefits of like a true ORM for things. And like, yeah, they were starting to come out like with very pretty good ORMs for Node, but you rewrite like your data access, and that's basically rewriting your application.
Right.
And so we didn't see like, I didn't see too much of a benefit in rewriting things in Node and still maintaining multiple services. When if we're going to rewrite things, let's just rewrite it in Ruby. All of the current developers also were very familiar with Ruby because they came from Chicago boot camps. And that would refine this down into a single service.
Okay. And since this is code that you had been writing and had control on, how did you feel about the test coverage? And one thing that we find with a lot of, whenever we say rewrite, and people say, oh, well, we have to rewrite because the old one is so bad and so terrible, and we don't know what it's doing. And then Isaac and I will then say, but then how did you ever figure out what it was going to be doing to rewrite it? It sounds like in this case, that wasn't a problem because you wrote it and you did a good job, and so you knew what the business logic was.
So we knew what the business logic was. When we had the multiple different services, remember, we still had to have these admin functionality where like, so this was a B2B, like at this point in time, this was like 2 years later, I described it. Initially, it was these like cleaning services and staffing services that businesses could contract with us for. And then we had like a pool of workers, and then we would distribute those out and schedule them, all that kind of stuff. By that time, that like third year, that had evolved into, yes, that business, but also like B2B commerce, basically. So all of these offices needed food and paper and cleaning products and anything else that is required to run an office and have people live in a building. And so we became a marketplace where they could browse catalogs from vendors like all over, like hundreds of vendors across the US and in different countries that won't necessarily usually sell to like individual buyers, but like would sell to us, like a big aggregate buyer. And then we would get like discounted prices and like all that other kind of stuff, and then display those prices for these our customers in these catalogs, and they could like order those products. So we would handle the purchasing from the distributors, the original vendors, and order routing and returns and refunds and all that kind of stuff. So this was now like B2B commerce system and a marketplace for all of this stuff.
You were like a middleman almost.
Exactly.
You were a middleman.
Exactly. So way more complex at this time for all those things. And so, okay, you were asking about test coverage. So as we were building out all of that functionality, right, we still needed to allow our support staff, like our account managers and all that kind of stuff, to create these orders and do all of the basic things that an actual user would want to do. Because again, this is B2B. So fully 50% of your users are just going to ask their account manager to do the thing for them. And so we had to build all that admin functionality and in that Rails application, and we wrote tests for all that stuff. So we already had tests for the basic like business operations in the Rails system. Because we were maintaining these microservices, we also wrote tests in the microservices for like the customer to do that operation as well. So basically for any operation, like creating an order, when we had the microservice architecture, we had to write test that, like, yes, the admin side of this would do the correct thing and the logic is sound, but then also we have to write the tests for the microservice side of it as well. So we were doubling those tests. And that's also where that like sluggishness came from when we were implementing these features, that we had to build, we had to prove correctness in like both places for any one individual feature.
Yeah.
But it did make this cutover somewhat easier, right? Because now all we're actually bringing over is we're exercising that business logic that we had already written in Rails or in Ruby. And what's new is we're building routing, like API calls and page rendering and stuff like that. So that's a much smaller like test suite that you have to write, obviously, to do that, and much less like sanity checking, right? All you're really worrying about is like, can it handle load? Can it be performant? Can it be maintainable, right? To do all those things, can it still be maintainable? So yeah, at this time I had written the basic implementation of like proving out that like, yes, the slowest routes and the fastest routes can be replicated over here. Wasn't that pretty because there were a lot of like thread juggling and that kind of thing. So I wrote some like basically like some DSLs, like some Ruby macros that would like do some of that consistent juggling so that it would make our routing like very simple and maintainable. And then we just started plucking individual microservices, copying over the functionality into like the new routes in the Rails system, making sure they were still as performant because we had baseline performance testing for all of our different services. Once that was ready, we do a cutover of copy the data into the either existing tables or new tables in the Rails database, and then just reroute any requests from clients from the old microservice to like these new routes. And they just repeated that for all of the microservices except for one.
So wait, could you go deeper into the act of cutting over? Because it sounds like you're saying, or you had the services, they were effectively equivalent. You then had to, I'm guessing you had to have a maintenance window.
Yeah.
Snapshot the database, move the data over, and then the new routing goes to the new system and the combined database.
Yep.
And then shut off the old one.
Yep.
How long was that maintenance window?
Usually like 5 to 10 minutes. Because we had different like test environments. So we were running all these things on Heroku at the time. So we had like a staging environment for every individual service. And we had a like load testing environment for some of the services as well. So we could just run through test executions of these cutovers over and over again. And for the first few of them, we had to do those test cutovers like many different times to like perfect, okay, yes, we're going to do this and this and this and this. But once you do it like for a few of the different services, the last few go down like dominoes because you're very familiar with like, okay, yep, we create the table over here. We know how to do a PG dump and upload over here. And we know how to do like a DNS reroute over here to like this thing. Like it's pretty simple.
So it sounds like one of the keys to making this work was you were able to automate the cutover. It was not a manual human-based cutover where you guys were in a war room and
no, these were still human-based cutovers. Yeah.
Okay.
But it was, luckily we didn't have to do it too many times. So, we only had maybe 12 of these. So we just took rotation. I mean, I did each one, but then like paired with different people. So like, okay, me and Eleni would do this one. Me and Mike would do this other one, like the next week or something like that. Some of them we could do during the day because it's just like a login server and we can accept no one going through a login session for 5 minutes. But other ones we did on a late Saturday night because that was like the lowest traffic time or whatever. And those weren't fun, but once people are pretty confident, it's not that big of a deal.
So I have a question about just the overall process. Because like when you think of people going the normal route, which is like a monolith, 2 microservices, I feel like you don't really have to prove that as much. I mean, you should, but there's like a lot of examples of this happening where like you can like, oh, this is the natural progression. So if you're inverting that, did you have to like make the argument to a lot of people, or did you get any pushback from like, whoa, we just improved it and made microservices. Why won't we go back the other direction?
Yeah. So I was lucky enough to be in an organization where I had a high trust with the other like senior leadership team. So we had like a head of product, head of design, me, head of engineering, and then like our co-founders and CEO. And everybody had the ultimate goal of like serving the customer. So they did not care on like how technically I decided like how we should go about serving that end result. What they cared about is, can we get the features they want? Can we get them on time? And so what the conversation I was lucky enough to be able to drive it to is, well, yes, we've been able to do this right now, or up to this point, based on this like current service architecture. But over the last month, we've had to spend X hours like doing this maintenance, or we've like neglected these maintenance things that we needed to do. Or, you know, this person just joined and they're unable to go work on this feature in this one microservice because they're unfamiliar with this system or something like that. Those like concrete, these are costs that we are going to pay, or we are already paying. And this is where they are going to go. Like they are only going to go up for these things. And either we need to hire more people or we need to reduce those costs. And we weren't going to hire more people at the time. So we had to reduce the cost. And then it became a matter of like, okay, well, it's not going to be acceptable for us. And I wouldn't want to do it this way of, well, we're going to spend the next month just doing service consolidation. This took place over the course of like 9 months, probably. Like it took a significant amount of time, but it was like, okay, yep, we just got to knock this one down. Okay. We went in order of like the highest usage as well. So I'm a big proponent of like, move the boulder before you move the stones. So like I talked about, like when I was doing the load test or the performance testing, you performance test on your slowest and fastest things, like the things that are going to be most consequential. And when we moved these microservices over, we moved the most consequential, like the heaviest used one, the one for like product catalog. When we were doing these e-commerce things, we moved the product catalog first. That's the highest like usage one, but it's also like, if we can do this one, every other one is going to be easier.
Interesting. Nice. Yeah, it sounds like you did a number of things that don't usually happen in a rewrite, which really saved your bacon. Like, well, you had the good test coverage. You went with the hardest stuff first instead of like proving it with the easy stuff and then discovering all the edge cases. You only had, you said you only, well, you consolidated down to 2 services. What happened with the last one that you didn't?
Well,
it just hadn't been done, or
so the Elixir server, we still like, it was working so well for the specific task of like these long running HTTP connections that it had to hold on to, that we decided not to migrate it over because the Rails architecture wasn't going to handle that as well. And so they were still running, or we were still running with that when I left.
Okay.
Yeah. I think that like I remember too, like when you're talking about doing the most impactful one first, the load bearing one, or like the largest boulder. That kind of it's like the inverse of the Nozomi one that we where Nathan was talking about doing the least risk item to begin with to kind of prove the concept. It was like the inverse of that. So I wonder if there's some wisdom in trying to tackle that largest one first.
Personally, I think so. I mean, I still preach that today at my current job or whatever, when we like, oh, we're going to prototype this big implementation. What are we going to prototype? Are we going to prototype like the easy thing that we can do in like a week that gives us a hint that this will work? Or do we prototype the thing that we're worried about that will actually disprove whether we should do this project or not? And like, I encourage people, you got to do the latter all the time, because otherwise you're not really proving anything to yourself. And I'm not more confident. I'm marginally more confident if we can do the easy thing. I'm much more confident if we can do the hard thing.
We had an episode a few back where we talked about the inversion of risk, where trying to do the least risky thing was highly risky for exactly what you're saying. Is because doing the least risky thing doesn't improve your confidence at all.
Yep. And so yeah, we finished migrating most of those microservices down, and that code got archived. And we continued to add more and more features. And it did accelerate our ability to add new things, because now literally any admin, account manager feature that we needed to add for like them to make a recurring cart order or whatever, that would be generally immediately available in like the API that we could offer. And so things became a lot more lockstep between offering it for a customer and offering it for like ourselves. Yeah.
Interesting. So now that you've gone through it and it's been a few years to sit and think about it, is there anything that you did that you wouldn't have done, like if you were going to go through the whole thing all over again? Because it sounds like all of your theories, when you went from Rails to microservices, you had theories that turned out to be wrong. But when you decided to pivot and go back to consolidate back into a Rails monolith, all of that, were there any theories that you had there that were disproven that turned out not to be right?
Yeah. It's interesting. So I didn't quite, and this is always the case with any large database, but you can never quite predict how it's going to perform as you expand different tables and like different usage patterns on your relational database. So that was a big thing, is we started spending a lot more time tuning that. Whereas before, when things were distributed across different databases, no individual one had to be tuned too much, like they were all like, oh yeah, this one has this query that it's doing that's like complex, but like, okay, we figured that one out. But when you consolidate everything into a single database, you tend to have interactions between those queries, right? Doing one expensive operation has consequences for others. So we did more tuning based on those interactions between things. I would say that was like unexpected, but I still think that was easier than doing the opposite maintenance. And I learned a lot that I still use a lot.
Awesome. Were there any, so no particular downsides, it sounds like.
Yeah. No, other than the time it took.
How long did it take?
I mean, yeah, like I said, so the full migration back probably took like 9 months to like finish doing all of them. We had a head of steam at the beginning to do all those. And also, like I said, we moved the bigger ones first. So we saw bigger benefit initially when we did the initial migrations. But there was a long tail of those. And, it's important I think when you do those like kind of migrations or rewrites to celebrate when each individual step happens. So like we would print out the code for like the thing and burn it, or like, tape it to the wall and like measure the stacks of things or whatever. We did that for a few of them.
That's a fun ritual.
Yeah, exactly. You just gotta like find something fun for that stuff to keep like people enthusiastic about it. And then also beat the drum of like, oh yeah, we're seeing these benefits or whatever from that stuff. So I don't know, it's unreasonably fun to hit archive on a repository, I think, and like see a bunch of PRs like close ahead of time, or we used to measure like how many dependency PRs we had to like merge. Like you can run queries on these things. How many dependency PRs were we having to manage this time last month versus now? And you see that number go down. Also things like, I highly recommend, if you're going to do something like this, migrate to here's what I would say. When I first started that microservice proliferation, I did not appreciate an old community open source community as much as I did at the end of that. I was much more like, oh yes, like I like Node, like Node is new and like performant and everything. But like as we built out more and more of the SaaS system, we found more and more Ruby gems from like 3 to 5 years ago that would do exactly what we needed to do, that we would have had to rewrite in a new language, even in JavaScript, which has also been around for a long time, but like just didn't have the same maturity in the industry that we were operating in. Yes, didn't have the same maturity in the industry we were operating in, which was like e-commerce things. So we saw big benefits of that later on when we're like, we would go to, we need to implement a new feature, and we could immediately within, a day find like a reasonably maintained gem or one that we could fork and like do our own thing with.
One last thread of things that often go bad, terribly wrong with rewrites is the human aspect of it. If you're moving to something new and fun, there's often jealousy amongst the developers who have to do the maintenance work, they keep the lights on the current stuff towards the people who get to do the fun stuff. Given that you had such a small team, relatively few services, and that you were consolidating to something that was already in there, like you weren't going from Ruby to Node, and people could get jealous about, oh, I want to try Node. How was the morale? Like, did you encounter any morale issues with the implosion? Implosion's the wrong word.
So, yeah.
The monolithization?
The compression, yeah.
The compression, that's good.
I would say that no. So one thing is, I personally was very motivated by this. I don't know. I have a very gardener mentality though on things. I would much rather like perfect something that we already have versus like build a new thing. That's me. So I was the one constantly pushing to like condense all these services down. Once I had like convinced like, yes, this is going to be beneficial and like worthwhile. So what that meant is like for any individual service, I would like pull in another team member to help me. Like, hey, Jane, you're going to help me like move this one over, and like Michael can go work on some new features, whatever. So we can distribute that load. But I was always like the one also bearing the brunt of like the grunt work on like reducing things. So maybe that won't be there in all cases for everybody else. But then what I would also say is that when we had a proliferation of services, I would say that there was actually more of that like motivation or competition factor in play, because people would say like, oh, I want to go implement this thing in Go. Why can't I do that? Like we already have another service, or like what's another service to go do this special thing in this one language I have. When we had condensed everything down to a single like implementation, like that monolithic implementation, it's now the default that you build in there, and you have to disprove that to go like build something new or in a new language or whatever.
That's interesting.
And so it actually, I would say, like reduced the number of those conversations because everybody was kind of like more on even playing field once you were getting it down.
Awesome. Isaac, do you have any more questions?
No, and I think yeah, we're kind of coming up on the later end of the episode, so I guess we can go ahead and transition to. Is there any anything you want to shout out to, Josh? Any kind of thing you want to advertise while you have a voice here, or do you want to throw out your links so someone can find you?
Oh yeah, shout out to open source. Shout out to Ruby and Rails, I will say. But no, you can find me online at joshbeckman.org, joshbeckman.org. I don't post much, but I try to post some interesting things, and I'm trying to do more open source work. An interesting thing I did recently is did like an index or a catalog of all the like open funding that I've been doing, because I think people should be doing that more. So let me know if you read that and have any feedback.
Will do.
Awesome. Well, thank you for listening. Thank you for coming on, Josh. I'm Jeffrey Sherman.
And I'm Isaac Askew, and this is Never Rewrite.